This is our lecture on mass spectrometry. So pictured here on the right is a mass spectrometer. It is an instrument that we use to determine the relative atomic mass of an element. And it is an instrument that's it's a very common instrument that is found in chemistry labs. If you take any chemistry lab classes in university or even at a college level, you'll probably use this at some point. A lot of universities have them. Besides just using it to determine relative atomic mass, which is what we're going to be talking about in this class, it can also be used to find unknown elements or an unknown compound by determining the atomic masses of all the elements that compose it and things like that. So you guys don't need to know how the machine actually works. You don't need to know the parts of the machine or how it does what it does. You more so need to understand how to read the graphs that the mass spectrometer produces. But I'm still going to just talk briefly about how it works. So, for your understanding, so just so you can understand. So the main thing is that molecules at the start are ionized, so they're charged into positive charges, into their positive charge. Then they're separated according to their mass to charge ratio. So they're separated depending on their size into different sizes. Then it's sent to the end of the spectrometer where a detector reads how many of each mass to charge ratios hit it at different points, and then it takes that information to create a graph. These graphs are called the mass spectrum. They plot the relative abundance of a molecule versus its mass to charge ratio, which for our case is generally the mass of an isotope. And then the height of each peak is how abundant each molecule is found in the sample, because that's what the y-axis is plotting. It's relative abundance. So as an example, here we can see magnesium. So the reading of the spectrometer when magnesium is put in. We see three different peaks. And if we look at our mass to charge ratio, which for our isotopes is just their mass, we can see that one of the isotopes has a mass of 24, so it'd be magnesium 24. One has a mass of 25, which would be magnesium 25, and one has a mass of 26, which would be magnesium 26. Then we see here we have their percent natural abundance as our y-axis. So to find out the composition of each of them, you would look at where the bar graph is. In this case, for example, magnesium 24 is about 79%, a little under where we see the 80 mark. For magnesium 25, we look over and it's about 10%. And then we look at magnesium 26, and it's like a little tiny bit taller than 25. So we'd say it's about 11%. And with that, just reading the chart, we have found our natural abundance of the three different magnesium isotopes, and then we could take them with their each individual masses and their each individual natural abundances, and we could calculate the relative atomic mass like we did in the last lecture right before this. So yeah, that's how a mass spectrometer works, and that's how we read the mass spectrum graphs that they produce. Thanks so much for listening. I hope you have a great day.